In this video, I will integrate cosine to the power of ax dx. Now, first of all, looking at the exponent here, it's an even number. That means it's more complicated to integrate than an integral with an odd number here. Because I cannot take our cosine of x here, which I cannot really use substitution. So I have to rewrite this as integral cosine square x to the power of 4 dx, because 2 times 4 is 8. Now, I have cosine square x in the middle here. I have to replace it with a trigonometric identity so that I can integrate this properly. But I'm not going to use 1 minus sine square x, because even if I replace 1 minus sine square x here, I don't have a cosine of x here. So even if I expand this, it's not easy to integrate. So I have to use this trigonometric identity here. Cosine 2x is equal to cosine square x minus sine square x. Now, I have a cosine square x here, so I have to isolate cosine square x here. And we know that sine square x is 1 minus cosine square x. So I can rewrite this as cosine 2x equal to cosine square x minus 1 minus cosine square x. Now, minus is plus, so cosine 2x is equal to 2 cosine square x minus 1. Add 1 to both sides, we have 2 cosine square 2 cosine square x is equal to cosine 2x plus 1. Now divide both sides by 2, so I have cosine square x is equal to cosine 2x plus 1 plus 1, all divided by 2. Let me switch the order here. So cosine square x is equal to 1 plus cosine 2x divided by 2. So I will rewritten cosine square x into 1 plus cosine 2x over 2. So I can substitute into this here. So that is integral of 1 plus cosine 2x over 2 to the power of 4 dx. Okay, so let's distribute the exponent to the numerator and the denominator. So we have 1 plus cosine 2x to the power of 4, all divided by 2 to the power of 4, which is 16. Now dx. Okay, let me separate this. Okay, 1 over 16 is just a constant, so I can move it out of the integral sign. So that is 1 over 16. Integral 1 plus cosine 2x to the power of 4 dx. Now the next thing is to expand this polynomial. Now this is to the power of 4. We can FOIL it 4 times, or we can use an easier way to do it, which is Pascal's triangle. Because if you just do it this way, if you just expand it like this, it's easier to make mistakes, it's more time consuming. So this time I actually have Pascal's triangle to expand this. So let's see. I'm gonna write this 1, 1 and 1. 1 plus 1 is 2, and then 1, then 1 on the side. 1 plus 2 is 3, 2 plus 1 is 3, and then 1 on the side. Then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1 on the side. I think we can stop here right now, because we know that we're expanding this polynomial, a plus b to the power of n, and we know that n is equal to 4 in this case. So the first row is for n equals to 0. The second row is for n equal to 1. The third row is for n equal to 2. The fourth row is for n equal to 3. And the fifth row is for n equal to 4. So that means after we expand this will be the coefficient in front of each term. And we can actually say that this is a plus b to the power of 4, because that's what we're trying to expand. Well, let's try to expand and see how it looks like. So the first coefficient is 1, the first term. So 1 times a to the power of n times b to the power of 0. b to the power of 0. Plus the second term coefficient is 4. So 4 times a to the power of n minus 1 times b to the power of 1. The third term with coefficient of 6. So it's 6 times a to the power of n minus 2 times b to the power of 2. plus the fourth term, coefficient is 4. 4 times a to the power of n minus 3 b cubed. Plus the fifth term, coefficient is 1. So 1 times a to the power of n minus 4 times b to the 4. Okay, so look at this. There's also pattern for the exponent. We see the n minus 0, 0, n minus 1, 1, n minus 2, 2, n minus 3, 3, n minus 4, 4. So whatever the number that n subtract in the exponent of a is the exponent of b. And the coefficient in front of each term is just this number here in the Pascal's triangle. Now, take a look at this, what we're trying to expand. 1 plus cosine 2x to the power of 4. So 1 plus cosine 2x to the power of 4. And we can say that a is 1 and b is, okay here, a is 1 and b is cosine 2x. So we can replace this into this and see how it looks. So the first term is 1 times a is 1 to the power of n is 4. b is cosine 2x to the power of 0. That's the first term. Second term, 4a is 1, a is 1 to the power of n minus 1, n is 4. 4 minus 1 is 3, 3. b is cosine 2x to the power of 1. Okay, the third term, 6 times, now a is 1 to the power of n minus 2, n is 4, 4 minus 2 is 2. b is cosine 2x to the power of 2, so square. Okay, plus the fourth term is 4 times a is 1 to the power of n minus 2, n is 4. 4 minus 3 is 1. b is cosine 2x to the power of 3, so 3. Plus the fifth term, here, 1 times a is 1 to the power of n minus 4, n is 4. 4 minus 4 is 0 to the power of 0. And then times b, b is cosine 2x to the power of 4. Here. Okay, so now we just have to simplify this and see. We write this. This is 1 plus the second term, 4 cosine 2x, plus the third term, 6 cosine square 2x, plus the fourth term, this is 4 cosine cube 2x, plus the fifth term, this is cosine 4 2x. Okay, so I have rewritten, I've expanded the 1 plus cosine 2x to the power of 4 into this. So I can replace this back to the integral here. So let's come back here. That's equal to 1 over 16 integral 1 plus cosine 4 times cosine 2x plus this 6 cosine square 2x plus this 4 cosine cube 2x plus this cosine to the 4th 2x dx. I'm going to distribute the integral sign and the dx to each term. So that is 1 over 16 times integral of 1 times dx is just dx plus integral 4 cosine 2x dx plus integral 6 this term cosine square 2x dx plus integral of this term 4 cosine cube 2x dx plus integral of this term cosine 4 2x dx. Now look at this integral here. Integral of dx is easy. Integral of 4 cosine 2x dx is also easy. How about cosine square 2x, cosine cube 2x, and cosine 4 2x? I have to rewrite these three terms into another trigonometric identity so that I can integrate this properly. So let's start with a cosine square 2x. Cosine square 2x. Okay, so we know that trigonometry identity here, cosine 2 theta is equal to cosine square theta minus sine square theta. I know that at the beginning I use cosine 2x, but I'm going to use theta here and I will show you why. Okay, so that's the cosine square. So we have to isolate cosine square. Okay, so we know that cosine 2 theta is equal to cosine square theta minus 1 minus cosine square theta. Minus minus is a plus. So cosine 2 theta is equal to 2 cosine square theta minus 1 add 1 to both sides. Let me write 2 cosine square theta on this side. That is cosine 2 theta plus 1. And divide both sides by 2. We have cosine square theta is equal to cosine 2 theta plus 1. Or divide by 2. Okay, so we have cosine 2x here. We have cosine square 2x here. And that's cosine squared theta. So what I would do is let theta equals to 2x. So I can replace theta. I can replace 2x with theta. Or I can replace theta with 2x. So that is cosine squared 2x because theta is 2x now. That is cosine 2 times 2x plus 1 divided by 2. So I have my cosine 2x here. Well, cosine square 2x, I mean. Cosine square 2x is equal to, now this is 2 times 2 is 4. Cosine 4x plus 1 divided by 2. So that is cosine square 2x. And we know that that will be easier for integration. Okay, so we find out what we will write cosine square 2x. Next, cosine cube 2x. So cosine cube 2x. So how do we write this? Since the exponent here is odd, we can take out one of the cosines. So I can write as cosine square 2x times cosine 2x. Now, cosine square 2x, I will rewrite this as 1 minus cosine. 1 minus sine square 2x. Now, times cosine 2x. Now, I have a sine and a cosine here. I can use substitution to integrate this. So that's fine. How about cosine 4 2x? But that's the same as cosine square 2x to the power of 2. So 2 times 2 is 4. And we did say that cosine squared 2x is equal to this. Cosine 4x plus 1 over 2. So that is equal to cosine 4x plus 1 over 2 squared. Okay, let's distribute the exponent to each term, to the numerator and the denominator. That is cosine 4x plus 1 squared, all divided by 2 squared. 2 squared is 4. So now we should expand this. 1 over 4 times cosine 4x plus 1 times cosine 4x plus 1. That is 1 over 4 times cosine 4x times cosine 4x, cosine square 4x plus, this is 2 cosine 4x plus 1 times 1 is 1. Okay, so these two terms will be easy to integrate. How about cosine square 4x? Well, we have cosine square. So we have cosine square theta equals to cosine 2 theta plus 1 over 2. So we can use this. Cosine square theta is equal to 2 cosine theta to cosine square theta is equal to cosine 2 theta plus 1. So that is cosine 2 theta plus 1. Divide by 2. And what I would do is let theta equal to 4x. So let theta equal to 4x. Then I can replace theta with 4x here. So that is cosine square 4x is equal to cosine 2 times 4x plus 1, all divided by 2. So I have cosine square 4x equal to 2 times 4 is a, cosine ax plus 1 over 2. So that is cosine square 4x. So I will have to rewrite this as 1 over 4 times cosine ax plus 1 over 2. So cosine ax plus 1 over 2 plus 2 cosine 4x plus 1. Now, let me distribute the 1 over 4 to each term. That is cosine ax plus 1. Now, this would be a. So, over a. Plus, that would be 1/2 cosine 4x plus 1/4. 1 plus 1/4. So, 1 times 1/4 is 1/4. Okay, so that is cosine 4 2x. Okay, I have all this rewritten into something that's easier for integration. So let's replace this integral here. So that is 1 over 16 times integral of dx plus integral of 4 cosine 2x dx plus this one. 6. Okay, let me just take out the constant here now. So 4 integral this times 6, move the constant out of the integral, 6 times cosine squared 2x. And we say cosine squared 2x as cosine 4x plus 1 over 2. So cosine 4x plus 1 over 2 dx. Then this term here plus 4 times integral of cosine cubed 2x. What is cosine cubed 2x? This one here, 1 minus sine squared x, 1 minus sine squared 2x times cosine 2x. 1 minus sine squared 2x times cosine 2x. So I can use substitution. Okay, plus cosine 4 of 2x. It's this. But I'm going to write in the next line. Plus integral of cosine ax plus 1 over a plus half cosine 4x plus 1/4. Half cosine 4x plus 1/4 dx. Let's double check. Yeah. Okay, so let's take out the constant if we still can for this. So that is 1 over 16 integral of dx plus 4 times integral of cosine 2x dx plus now. This is 6 over 2 is 3. 3 times integral of cosine 4x dx plus 3 times integral of dx. Because this is 3 times 1 dx. 3 integral of dx. Now plus, okay, we will keep this one as it is, so we can use substitution. 4 integral of 1 minus sine square 2x cosine 2x dx plus, now here we can take the 1 over a out, integral of cosine ax plus 1 over a integral of dx, because that is 1 times dx and 1 over a plus this one here, 1/2 integral of cosine 4x dx plus 1/4 integral of 1/4 dx, which is 1/4, take out constant, integral of dx. Okay, we can integrate this. So 1 over 16 times, now integral of dx is just x, plus 4 times integral of 2x, or integral of cosine 2x is 1/2 sine 2x, because the derivative of sine 2x is cosine 2x times 2. Then 1 over 2 times 2 is just 1, so offset with the 1 here. Okay, this one must be 3 times 1 over 4 sine 4x plus 3x, because integral of dx is just x. Okay, plus, now this one here, we have to use substitution. So times 4, no, plus 4 times plus 4 times, now this 1 minus sine square 2x times cosine 2x dx. Let's do this. Integral of 1 minus sine square 2x times cosine 2x dx. I will let u equals to sine 2x. du over dx is equal to 2 cosine 2x according to the chain rule. Derivative of sine 2x, cosine 2x times derivative of inside, which is 2. I have to isolate dx to replace dx here. So dx is equal to du over 2 cosine 2x. So let's rewrite this integral. That is integral of 1 minus, now sine 2x is just u, so that will be u squared times cosine 2x times what's dx? dx du over 2 cosine 2x. Cosine 2x and cosine 2x cancel out. All you have left is 1 over 2 is a constant. We can bring it off the integral sign. That is 1 minus u squared du. We can integrate this. That's 1 over 2 times u minus add 1 to the power divided by the new power. And we say u is equal to sine 2x. We have to replace u with sine 2x. That's 1 half sine 2x minus sine cubed 2x divided by 3. Now we can distribute the 1 over 2 here. So that is 1 over 2 sine 2x minus 2/3 sine cubed 2x. So that is the integral for this. We can put that in. So half sine 2x plus or minus 2/3 sine cubed 2x. So 2/3 sine cubed 2x. Okay, so next, this one here. So we have plus now 1a times integral of cosine ax must be 1 over a sine ax plus 1 over a integral of dx is just 1 over ax plus half integral of cosine 4x must be 1 over 4 sine 4x plus 1 over 4 integral of dx must be 1 over 4x. Okay, so the rest you can distribute 1 over 16 to each term and then cancel out the constant, then you will get the final answer. But for now, I will leave it here. So I will press C because I'm finished. So that is the integral of cosine to the power of ax dx. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.